Alright guys, in this section we're going to look at creating quadratics and solving them using modeling. And modeling refers to kind of real-life examples. So let's take this one here. The height of a golf ball is modeled by the equation below, where h is the height in feet and t is the time in seconds. How long is the ball in the air? What is the highest point of the ball? And at what time will the ball reach its maximum height? Now in this equation they give you this f of x, and we've always known that that is y, or in this equation it's the h. Okay, so that's your height. So that's another way of looking at this. Alright, so what we've got is this equation. We've got to think of what this represents. So think that you have a graph here. We hit this golf ball, and we're looking at this based on time. Time is normally our x value. That means that h is your height, and that's your y value. Okay? So we hit the golf ball, it's sitting on the ground, it gets hit, it's going up, at some point it's going to reach its highest point, and then it's going to start to come down. Now what you have to understand, this is not the distance that it's traveled. This is just how high it is over a certain amount of time. Alright, so what we're looking for is how long is the ball in seconds, or how long is the ball in the air. So we want this time there to there. Okay, that's the first thing. The second thing is what's the highest point of the ball. So if you think of this, we want our maximum. And then at what time does it reach its maximum? So we want to know what's that time right there. So those are some of the things we're looking for. Alright, so let's check it out and see what we can do. We can start by saying we know that the ball reaches that point at the end of its time. Well, what's the height there? Well, that's when the ball hits the ground again. So your height is 0. So I can take my equation and say that my height is 0, and it still happens whenever that t is whatever my time in the air represents. So I'm going to take and substitute the 0 in there, and I'm going to solve this. And you can use any of the methods that we've already talked about, but factoring tends to be the easiest method. So I'm going to look at this and say what can come out of each of those two factors. And I could take a 4 out of 16 and 76, so I'm going to factor out a 4 and a t. Now even better, I could take out a negative 4t, and the reason is what I'll show you here. Now if I take that negative 16t squared and I factor out the 4t, remember that's division, so negative divided by negative is a positive, 16 divided by 4 is 4, t squared divided by t is t, so in that first term I'm left with 4t. The second one, I've got 76t divided by a negative 4t. Well, positive divided by negative is a negative. 76 divided by 4 is 19, and t divided by t, those two things cancel each other out. And so I'm left with this. Okay, so I take each of these and I solve them. And remember, again, this is what's called the zero product property. I take each part of that and set it equal to 0 and solve. Well, for this first one, if I solve for t, I get t equals 0. That makes sense because that 0, which is right here back in my graph, I am on the ground, and that's when time has not started yet. Okay, the other one is solving this. So I'm going to add 19 to both sides. I got 4t equals 19. Divide 19 by 4, and I end up with my time as 4.75 seconds. That is how long the ball is in the air. There's my first answer. Okay, now I started at 0. The ball hit the ground at 4.75 seconds. When should this thing reach its highest point? Well, if you think about it, it should happen directly in the middle of its flight. So if I take my 4.75 and I cut that in half, I'm going to get 2.375 seconds. That is when the ball reaches its maximum height, which is what it's asking for right there. Now the last part of this is what is the highest point of the ball. And there's a couple ways you can do this. You can use our vertex formula to solve this out, basically trying to figure out what the maximum is. The other thing is we know that it happens at this time. So our t is 2.375 seconds, so I can just substitute that into my problem and get exactly how high that is. So my height is equal to negative 16 times 2.375 squared plus 76 times my time again, which is 2.375 seconds. All right, and I'm going to put this in. Give me 1 second. I'm going to put it through my calculator. You guys can do the same thing at home. And I end up with a maximum height, so this point right here is 90.25 feet. And there you go. So you hit this golf ball, it stays in the air for 4.75 seconds. It reaches a maximum height of 90.25 feet, and that happens at 2.375 seconds, and there you go. So from what they've given us, we can solve all of this information. All right, your assignment will be to work through some of these. If you need my help,